Good morning, student. In the last classes, we are seeing the chapter limits, under which we are doing the practice of questions. Today we will see some other question. Let's see. Our first question is, limit x tends to 0 sin x to the power n by sin x to the whole power m. Okay, students, so this is our question and we have to find the limit of this question. Okay, and we have to give when m is less than n. Okay, so student, first of all we will write limit x tends to 0, and this is sin x to the power n by x to the power n, and we multiply x to the power n, and the whole divided by sin x to the whole power m. Okay, now student, we will separate the limit, okay, in numerator and in denominator. So we write limit x tends to 0 sin x to the power n by x to the power n into x to the power n, and by limit x tends to 0, and this is sin x and by x to the whole power m into x to the power m. Student, we have multiplied with x to the power m and divide with x to the power m. So here is m power, so we can write sin x by x to the whole power m into x to the power m. Now students, we can see that this part is equal to 1 and this part is also equal to 1, so we can write limit x tends to 0 x to the power n by limit x to either student, we can write this is x to the power n minus m, and here this is 1 by 1. Okay students, now 1 into limit x tends to 0 x to the power n minus m. Now student, we are putting the value of limit 0 here, so we are getting 0 to the power n minus 1, and you know student, if we are writing anything in the power of 0, we get always 0, so result will be equal to 0. I hope you understand. Let's see once again students. This is our question, limit x tends to 0 sin x to the power n by sin x to the whole power n. So first of all student, we have multiplied with x to the power n and divided with x to the power n, and this is our denominator. Now student, limit x tends to 0 sin x to the power n by x to the power n into x to the power n. Okay, and this is sin x to the whole power m. So student, again we are multiplying with x to the power m and x to the power m. Okay, and divide with x to the power m. So we can write in this form sin x by x to the power m. And student, we are seeing that this part is 1, this part is 1, with this, because these are the standard result. Okay, so we can write a to the power m by a to the power n, so a to the power n minus m. Okay, so we write x to the power n minus m. Now when we put the limit x is 0, we get a student 0 to the power n minus 1, which is equal to 0. I hope you understand students. Now we take another question students and solve it. Let's see. Our next question is limit x tends to infinite under root a square x square plus ax plus 1 minus a square x square plus 1. Okay student, so limit x tends to infinite Now student, this is in the form of root. So student, first of all we will rationalize this part. Okay, we will rationalize it. Okay student, so first of all we rationalize this. Okay, so first of all we rationalize this. So we can write multiplied by under root a square x square plus ax plus 1 plus under root a square x square plus 1 and divided by a square x square plus ax plus 1 under root plus under root a square x square plus 1. Okay. So students, now after simplification we write limit x tends to infinite, and this part will be a in first bracket a minus b, in second bracket a plus b. So we can write a square minus b square. So a square plus x, a square x square plus ax plus 1 minus a square x square plus, sorry, here is minus 1, and in the denominator we write a square x square plus ax plus 1 plus under root a square x square plus 1. So students, we are seeing that this part is cancelled and this part is cancelled. So the remaining term is limit x tends to infinite and we get ax. And students, we are taking common here. Taking x outside, we get inside bracket a square plus a by x plus 1 by x square. Taking x here outside, we get inside student a square plus 1 by x. Okay. Now limit x tends to infinite ax y. Student, we are taking common x, so we get a square plus a by x plus 1 by x square. Okay, and plus under root a square plus 1 by x square. Okay students, now we are seeing that this x and x will cancel, and now we put the value of limit, we get what? Under root, this part is a square and this part is 0 and 0, and here is square under root a square and this is again 0. So we are writing a by 2 under root a square. So a by 2, a and a cancel. So our result will be what? 1 by 2. I hope you understand students. Let's see once again. This is our question and we have first rationalize it, multiplied by this and divided by this. Here in the numerator we are seeing that in first bracket a minus b, in second bracket a plus b. So we can write a square minus b square. So our root will be removed and this part will be changed with negative sign. So this two part will be cancelled and the remaining term will be ax. And here we are taking x outside. So we get here a square plus 1 by a by x, 1 by x square x under root a square plus 1 by x square. And this x and x will reduce from here student when we take outside from the denominator x. Now we put the limit here, this part will be 0, this part will be 0 and this part will be 0, and in the denominator we get root a square, it will be 2 root a square, so we get 2a students. So our result will be what? 1 by 2. I hope you understand students. Now we take another question. Let's see student. Our next question is next question is student, limit x tends to 1 log 5x base 5 to the whole power log 5 and base x. Okay, student. So this is our question and we have to find the limit of this question. Okay. So let us start. Limit x tends to 1. This is log m plus log n. Okay, student, we can write in this form. Now, student, you know that the property of log is that if base and that term whose log is finding, if both are same, then its value is 1. So we can write log x base 5 and to the whole power log 5 base x. Okay. Now, student, this is our fx and this is our gx. So we apply, we know that this is the form of 1 to the power infinite. So we can write e to the power limit x tends to 1 and this is 1 plus log 5x minus 1 fx minus 1 into gx, and our gx is log 5 base x. We are saying that this part is cancelled, student. So e limit x tends to 1, this is log x base 5 and this part we can write, student, 1 by log 5 x. Okay, student. Okay, students. So this is log 5x and sorry, here is mistake. We can change this. We write 5x because this is the property of log. We know log base a m, so we can write log m base a. This is by using this property we can write this. So this part will be cancelled. So it's going e to the power 1. So answer will be e. I hope you understand, student. Let's see once again. Limit x tends to 1 log 5x 5 base and to the whole power log 5x. So student, this is log m into n, so we can write log m plus log n, and this part is when base and this part is same, we can write its value is always 1. So this is log x base 5 and this is log 5 base x. Okay, student. Now we are saying that when we are putting the limit, we are getting this is the of the type fx to the power gx. Okay. So we write fx minus 1 into gx and e to the power limit x tends to 1 fx minus 1 into gx. Now this is cancelled and this is log 5x and this is 1 by log x 5. By using this formula, this will be cancelled. We get e to the power 1, which is e. That will be our required answer. I hope you understand, students. Now we take another question and solve it. Let's see. Our next question is our next question is, student, limit x tends to 1 log 2x 2 to the power log 5x. Okay, students. So this is our question. We have to find the limit of this question. Now, student, started solution. Limit x tends to 1. This is again we can write log 2 and 2 plus log x base 2 and this is power log 5x. Okay, students. This is log m into n and log m plus n. We have directed. Now limit x tends to 1. This is 1 plus log x base 2 to the power log 5 base x. Okay. Now this implies, student, we can write fx minus 1 into gx. Okay, so we write limit e to the power limit x tends to 1. This is 1 plus log x base 2 minus 1 into g x. Okay, student. Now e to the power limit x tends to 1. This is cancelled and we get just log base x2 to the power log. Sorry, this is n into log 5x. Okay, student. Now this we can write e to the power limit x tends to 1. This is, we can write log x base 2 1 by, and this is log 5 base x. So student, this we can write e to the power limit x tends to 1. This is log 5x by log 2 base x. So we can write e to the power limit x tends to 1. This is, we can write log 5 base 2. Okay, and this is limit x tends to 1, so we can write e to the power log 5 base 2, and this will be our required result. I hope you understand, students. This is the same question like previous question. Again we are changing into m plus n. Okay, and its value is 1. So again we are applying fx to the power gx. So e to the power limit x tends to 1, fx minus 1 into gx, and this 1 and 1 will reduce. Okay, student, and we get log x2, and this is gx, and this part we can write log 2 1 by log 2 base x, and this is, we can write log 5 base 2, and answer will be log 5 base 2 e to the power log 5 base 2. I hope you understand. Now we take another, student, another question. Let's see. Our next question is our next part is limit h tends to 0 log 1 plus 2h minus 2 log 1 plus h by h square. Okay, so limit h tends to 0. Student, we can write log 1 plus 1 plus 2h minus log 1 plus h whole square and by h square. This is log n to the power n. Now student, limit h tends to 0, we write log 1 plus. Now student, from here we are taking negative sign outside, we get log 1 plus h square minus log 1 plus 2h and by h square. So limit h tends to 0, we write log 1 plus h square by 1 plus 2h, student, and this is h square. So minus limit h tends to 0, student, this log and 1 plus h whole square we can expand 1 plus 2h plus h square by 1 plus 2h and by h square. Now student, limit h tends to 0, we can separate this term. This is one term and this is second term, so we can write log 1 plus h square by 1 plus 2h by h square. Okay, student, Now limit h tends to 0, we can write, student, log 1 plus h square by 1 plus 2h by h square by 1 plus 2h. We have divided with this and now multiply with this term. Okay, student? We are dividing with this term, dividing with 1 plus 2h and multiply with 1 plus 2h. Now, students, we are seeing that minus limit h tends to 0 log 1 plus h square by 1 plus 2h by h square by 1 plus 2h and limit h tends to 0 1 by 1 plus 2h. Now, student, this part is 1 and this is, when we are putting the limit h is 0, what we are getting? We are getting 1 plus 0 and this is minus 1, and this is our required result. I hope you understand, students. Let's see once again. This is our log 1 plus 2h minus 2 log 1 plus h by h square. Now limit h tends to 0, we can write log m to the power n, this 2. Okay, so we send log 1 plus h to the power 2 and this is h square. Now, student, we are taking negative sign outside. We get log 1 plus h square minus log 1 plus 2h. Now this is log m minus log n, so we can write log m by n and this is our h square. Now, student, this is a plus b whole square, so we will expand this. So we write log 1 plus 2h plus h square by 1 plus 2h by h square. So minus limit h tends to 0 log this part. Now we are separating these two. Okay, so we write 1 plus 2h by 1 plus 2h and h square by 1 plus 2h. So this part will be 1 and plus h square by 1 plus 2h. So limit h tends to 0 log 1 plus x. Okay, student, so this is our x. Now this is h square. So for making like an standard result, we are dividing with 1 plus 2h and multiply with 1 plus 2h. Now we are seeing that this part is equal to 1 and we are taking the limit with also this part, which is limit h tends to 0 1 by 1 plus 2h, student. So this part will be 0 here and this is 1 by 1. So result will be minus 1. I hope you understand, students. Let's see another question. Our next question is limit x tends to 0 a to the power x plus b to the power x plus c to the power x by 3 n to the power 1 by x. Okay, student, this is our next question. And friends, we are seeing that when we are putting the limit, we are getting what here? A to the power 0, b to the power 0, c to the power 0, and its value will be 1 plus 1 plus 1, 3 by 3. It will be 1 to the power infinite. So this is of the type 1 to the power infinite, student. So you know we use in this form a to the power limit x tends to 0 and this is our fx minus 1 this is our fx minus 1 and into gx. Okay, student, so we can write in this form. So e to the power limit x tends to 0 we write a to the power x plus b to the power x c to the power x minus 3 by 3 and 1 by x. Okay student, I hope you understand students. Now student, we will make this. We write e to the power limit x tends to 0, and this is, we can write a to the power x minus 1, b to the power x minus 1 and c to the power x minus 1 by 3. Okay. Now student, we are making this e to the power limit x tends to 0, which is, we can write student a to the power x minus 1 by x, b to the power x minus 1 by x, c to the power x minus 1 by x, and here we are writing 1 by 3 student. Okay. Now student, e to the power 1 by 3, and we are sending the limit inside, we get limit x tends to 0 e to the power x minus 1 by x, limit x tends to 0 b to the power x minus 1 by x, plus limit x tends to 0 c to the power x minus 1 by x. Okay student. So from here student, we are seeing that this is e to the power 1 by 3 and this is log of a and log of b and log of c. Okay, and this we can write again log a b c student. Okay student, now this we can write limit log a b c to the power 1 by 3, and this is, we can write a b c to the power whole by 1 by 3, and this will be our required result, because e to the power log e, this will be equal to 1, and we write a b c to the whole power 1 by 3. It will be our required result. I hope you understand students. This is important question. Let's see once again student. First of all, when we are putting direct the limit, we are checking that this is 1 plus 1 plus 1 by 3, so 3 by 3, so it is 1 to the power 1 by 0, which is infinite student. Okay, so we are getting student, this is of the type 1 to the power infinite, and you know its form is what, how we will solve such type of limit. We write e to the power limit x tends to 0 fx minus 1 into gx. This power will be changed into. Okay, now we will take LCM student. We write a to the power x plus b to the power x plus c to the power x minus 3 by 3 and 1 by x. Now this 3 can be written as a to the power x minus 1, b to the power x minus 1, c to the power x minus 1 by 3 and 1 by x. Okay students, now this 3 we are taking outside, and this 1 by x we are sending inside the bracket. So we are getting a to the power x minus 1 by x, b to the power x minus 1 by x, c to the power x minus 1 by x. Okay, so 1 by 3, limit x tends to 0, here a to the power x minus 1 by x. We are taking limit with each term separately. Okay, so this is with the limit, this term is with limit, and this term is with limit. And you know student, this is an standard result, so its value will be what, equal to log a, log b and log c. Okay, so this can be written as log m plus log n plus log p. So we can write log m n p. So here is a b c, so we can write log a b c, and 1 by 3 is our outside. Okay student, so this we can write e to the power log abc to the whole power 1 by 3, because this we can write log n to the power n, so it change in n log m, so we can write log n to the power n. Okay, now this part is equal to 1, so we can write ABC to the whole power 1 by 3. I hope you understand, friends. So thank you so much. Now we will see some other question in the next class. Thank you.